Okay, everybody, we're back. We're in video number 2 now. I'm just going to mark that as video number 2. This is Intro to Verifying Trig Identities. I've already given you some of the resources and the skills that you're going to need. So study those and make sure you know how to compose and combine fractions. All right, this is Rex number 1, remote example number 1. All right, you might see something like this, verify. Okay, so I'm going to start with 1 plus the cotangent of theta is equal to cosecant squared of theta. Okay, note, if your problem on your problem set sheet uses x as your angle, you can keep it as x or you can change it to theta. I always resort to theta just out of habit, but it really doesn't matter, whatever you're okay with. Okay, so we are going to take this side, this is the more complex side, okay? So it's a little bigger than this side, this is a single statement. So we're going to start with this side, okay? Our goal is to use the identities and turn this into cosecant squared theta. So when we're finished, on the left, we should have cosecant squared theta equal to cosecant squared theta, and we will have verified our identity. All right, so I'm going to look at this and go, okay, I know that this is cosecant squared. And I know that if I wanted to put it in terms of sine and cosine to help me have a target, then I could say, you know what, my target would be, okay, because we agree that in the reciprocal identities, cosecant is 1 over sine, but cosecant squared is also 1 over sine squared of theta. So this is kind of my target. Okay, if I can get it to here, then I've automatically got the red statement. All right, so I'm going to look and I'm going to say, okay, I've got 1 plus, and since I'm aiming for sine to come into play here, I'm going to restructure this in terms of sine and cosine. All right, and I left off a squared. That is my bad. That should be a squared there, folks. So it's 1 plus cotangent squared. All right, so I'm going to decompose this into terms of sine and cosine. So cosine squared of theta over sine squared of theta. Why did I do that? Because I'm aiming for something with sine squared in it, not cotangent. I've got to cover this because 1 over sine squared is going to ultimately give me cosecant squared. Now I've got two fractions that are unlike. So 1 over 1 plus cosine squared of theta times sine squared of theta. Okay, so this is why I started with the complex fraction deal at the beginning. I mean, not complex, unlike. So we're going to multiply those together to get our denominator. That's simply going to give me sine squared theta. And then we have to cross multiply, right, to get our new numerator. So the left diagonal is 1 times sine squared of theta, which is simply sine squared of theta, plus, that's my operation. The other diagonal multiplication is cosine squared of theta times 1, which is simply cosine squared of theta. Okay, now in my next step, you need to recognize what you've got sitting upstairs in your numerator. Well, what this is the Pythagorean identity. And you know that sine squared of theta plus cosine squared of theta always equals 1. And you have sine squared of theta in the denominator still. And look at there. We made the match. So we can confidently say that cosecant squared of theta, right, because 1 over sine squared of theta gave us our cosecant squared. So now we have a perfect match to the right-hand side. So we have verified that identity. Okay, that was a very basic one. I want you to get used to seeing cosine squared of theta and sine squared of theta together and those variations of the Pythagorean identity. Okay, so just kind of get used to that. So these are all different. There's not necessarily one way to start one, except to remember start with the most complex side. Somebody may take a different path than I do and end up with the same answer. As long as they're all tied to those formulas and identities on your sheet, then that's fine. Some of us may take 10 steps, and some of us may take 4 steps. Doesn't matter as long as your end result is legit and you didn't make up your own math rules along the way, okay? So we ended up with exactly what we meant to do. All right, that's Rex number 1. All right, Rex number 2, and they all come in different sizes and shapes, okay? So there's no guarantee how big or how little or how long or how short they will be. All right, Rex number 2. In verifying trig identities, okay? Verify. Okay? The left side is tangent of theta times cosine of theta equal to sine of theta. Okay, well obviously we're going to start with the left side because it's more complex. Obviously it's got two terms and that's one. This is kind of a no-brainer. Okay, so whoops. Drop my microphone, sorry. Give me a second. Sorry guys. Technical difficulty. Okay, so we're going to aim for sine of theta. Well, this one's pretty simple. I know that I have two ratios that are going to involve sine, cosine. I'm aiming for sine. This is our goal. Okay, so I automatically know that tangent is the same as saying sine of theta over cosine of theta. And I know that cosine of theta just stays cosine of theta. I don't want to get rid of him or change him into 1 over secant theta or anything weird because I'm going to end up with sine of theta. Well, you can see what happens here. These are going to cancel. I'm going to be left with sine of theta on the left, and we've made a match to our sine of theta on the right. So we have verified that identity. Okay, so take a look at that. Super easy. That was multiplication. Multiplication ones are normally more easy than the addition and subtraction ones. All right, I think I've got time for another example. I think I'm going to have to make a third video because now I'm paranoid that my video, I'm going to have to splice it if I don't cut it. And I did learn how to do that though, so I'm pretty impressed. And that was actually on one of y'all's. I had to splice it, and that's why you would have 2 on one day. Okay, so we're on day 1 of Intro to Trig Identities. This is video number 2, Rex number 3. All right, verify. All right, 1 plus sine of theta times 1 plus sine of negative theta. Aha! So now this one is going to bring into play our even and odd functions, which is at the bottom of your formula sheet. Okay, well clearly if we're aiming for this, okay, we're aiming for this, this is going to be the start side. So we're going to start here. All right, first thing you recognize, you've got a negative theta employed into or embedded into a sine function. Well, this is an odd function. So since it's an odd function, it's going to have a little bit of an effect on this. So we're going to rewrite it. 1 plus sine of theta stays put. This is essentially going to be now 1 plus negative sine of theta because that's the result of an odd function. Okay? So sine of negative theta gives us a value of negative sine of theta. All right? So we can rewrite this yet again. 1 plus sine of theta times 1 minus sine of theta, because that's the same thing. And now I bet you recognize that what you have here are conjugates. Yes? Conjugates. All right, so conjugate multiplication, you don't have to FOIL it. Remember, you're simply going to square the first term, always subtraction, and then you're going to square the second term. So we squared the first term, and that's going to be sine squared of theta. Okay, so we're left with, let me put little arrows so you can identify the steps. So 1 minus sine squared of theta happens to be a variation of the Pythagorean identity. If you look at your Pythagorean identity, if you isolate cosine squared of theta on the left, okay, you would have 1 minus sine squared of theta on your Pythagorean identity. All right, I'm looking at that, so now I know that 1 minus sine squared of theta is equal to cosine squared of theta. So this converts to this because of the Pythagorean identity, and it matches the right-hand side of the given problem. So we have verified the left side equal to the right side. Okay? Now that's why you're going to have to recognize conjugates and perfect difference of squares and factoring and all of the skills. They all apply to these trig ratios and these trig identities. Sorry, my microphone is giving me a fit. Okay, I'm out of time on this one. I'm going to stop so I'll be able to post it, and I'll go into video number 3.